right, let's take a look at the next piece of notes. The next piece of notes is force. All right. So on force, we talked about speed, which was the equation up here, distance divided by time. And then we talked about velocity, which is speed, but then we got to add a direction to it, whether we're saying north, south, east, or west. And then we talked about acceleration, which was acceleration is that final velocity minus initial velocity divided by how long does it take me to change that speed, right, or change in time, okay? So that was what we've talked about so far. Now we got to look at what force is. Well, force, according to your notes that you've already written down, is it's a push or pull put on another object. So whether you push something or whether you're pulling on something, that's what a force is, right? So examples that I listed was a baseball bat and a ball, right? The ball, when you swing and hit that ball, right, you're exerting a force on that ball. You're putting a push on it and causing it to go off in the other direction, which, hopefully we hit it, but I'm not really great at that either. So I'm not going to say that I'm going to hit the ball every time. Kicking a football. The football is just sitting there. You kick it. You exert a force on it, hopefully causing it to accelerate in one direction. Right? You stomp your foot. You're actually exerting a force on the earth. The earth doesn't really move, but you are exerting a force on it. Okay? The floor while you're standing there. That's kind of crazy. You're just standing on the floor actually exerts a force, but you are actually exerting a force on the earth. Right? You're pushing up against the earth. Right? And ultimately, we're going to find out that actually exerting a force against another force, which happens to be gravity pulling down on you. So what happens if all of a sudden your legs give out and you're not pushing up with the same amount of force that gravity is pulling down? Where do you go? Boom, you fall to the ground because gravity pulls you down, right? So you are actually exerting a force as you stand up, pushing up. All right, we can even say that a chair that's just sitting there is actually exerting a force up against you while you're sitting there watching this video, because it's pushing up on you while gravity's pulling down upon you. Right? So on that idea, we got to look at there's a couple different types of forces. First one is a balanced force. Right? And a balanced force, the way in which I always like to describe it, you got to think back to when we've had homecoming games and we had tug of war. And if you got two teams pulling on the tug of war rope, right? So you got, seniors on this side, juniors on this side, they're both pulling, right? If they're both pulling and the center of the rope ain't changing, you're just sitting there, they're both pulling on the rope, right? It should be like going this way or going that way, but it's just sitting there, right? Then we have a balanced force. Are both classes exerting a force? Oh yeah, they sure are. They're pulling with everything they got to try and beat the other class, but the rope ain't moving, right? So we have equal forces in opposite directions. So I put down in the notes, example of a balanced force is a tug of war with no winner. So nobody's winning at the time. All right, and then the scientific piece to it is it's really an instance where there is no change. There's no change in the motion. The rope is just sitting there in one spot. So if we go back to the idea that I just said a minute ago about a chair, you're sitting in the chair right now. That chair exerting a force up, and you're exerting force down on the chair. Is that a balanced force? Yep, as long as the chair don't break. All right, so as long as the chair is just sitting there and it's exerting a force up and you're exerting a force down, those two forces are exactly the same. It's a balanced force. Now, if all of a sudden the chair breaks, then you're going to accelerate and go down and end up landing on the floor, which I hope doesn't happen to me right now. So balanced forces are forces where it's equal in opposite directions. All right, same thing would be happening is when I'm standing up. Excuse me, goodness. When I'm standing up, I'm exerting a force upward. Gravity is pulling down on me. It's an equal force as long as my legs don't give out. As long as my legs are pushing up, we have a balanced force and I stay standing upright. Okay. All right, the next one is called a net force. A net force is when we have a difference in the two forces. So now we got a tug of war, the two classes are pulling on it, and the rope is doing this. It's going in one direction. So who's exerting a bigger force? Well, the ones on this side, they're exerting a bigger force to make it so that the rope goes that way. These guys over here aren't exerting as big a force and they're losing. But are these guys exerting a force? Sure they are. They're still exerting a force. It's just their force is smaller than the force that's on this side. And because there's a difference in the two forces, then what we find is that there is an acceleration. Acceleration, go up here. Acceleration was a change in speed over time. So initially they're both sitting there, balanced force. They're both pulling, all of a sudden it starts to speed up, going this way. That's acceleration, starts to change its speed. and the rope starts to go this way because these guys are exerting a bigger force than these guys. And we end up with a net force, which causes it to accelerate in that direction, making this class over here win. All right. So my definition on that one is net force is a difference between the two forces. There's a difference occurring between them. So on this one, my example is tug of war with a winner. One of the two classes is going to win. And it's the one that's exerting a greater force. Now remember, it's not because they're the only one exerting a force. The other side is exerting a force, just not as big as the opposite one. So the one that's got the greater force, that's the direction that the object is going to accelerate in. So this says it causes a change in speed. So it's going to cause a change in speed. It might cause a change in direction, or it might cause both. All right. So you think about this, it's like just sitting right there, and you could have that one team goes this way, so they all of a sudden have a greater force, and then all of a sudden the other team puts a little burst on, and all of a sudden it changes direction and it changes speed going the other direction, and they finally win. All right. So we had a net force this direction, then we had a net force that direction. Oh, we had a balanced force at the very beginning. So we had this constant change of forces going on during that tug of war. All right. So that's what a force is. All right. So remember that force it can be a balanced force, equal in both directions, or it can be a net force where one of the two forces is stronger than the other and causes an acceleration in that direction. Okay, so that's the end of the notes for today. Today's notes are pretty short, but you have a good day. We'll see you.